Okay guys, good morning. Welcome to another tutorial. In this video we are going to talk about how to use V-Carve to cut out foam panels. So sometimes we have to make prototypes that require XPS foam. That's the 4x8 pink foam sheets out in the shop. And when we have prototypes, we have custom sized boxes. So that means we're going to have to cut out custom sized foam panels. So that's what this tutorial is about. It's going to be to show you guys how to lay those foam panels onto a sheet in V-Carve and then use the software to make a G-code to cut those out. So we'll go ahead and start by creating a new file. And all of the foam boards are 4x8 foam boards, so 48 by 96 is good. The thickness will depend on the thickness of the foam. We use everything from 1/2 inch up to 3 inches. So for now, let's just go with a standard 1 inch thick piece of XPS. We're going to 0 on the material surface, none of that changes, and our XY datum point is at the origin 0, 0. So our job setup is complete. Go ahead and press OK. So the first step, before you are going to cut these foams, is you will have already made the shells. So you already know what the box's ID is. And based off of that box's ID, you can get dimensions for your front, back, left, right, top, and bottom foam panels. So let's just assume that we are using a 12 inch by 12 inch by 12 inch standard box. So let's make some foam panels for that size box. So we can go over here into the Create Vectors tab and click on this Draw Rectangle. And that pops up this little drawing user form here. And this is where we can make our panel sizes. So this anchor point up here, this is where on this 4x8 sheet that this square is going to pop up. So I put everything a 1/2 inch from 0, 0. So we'll put X 0.5 and Y 0.5. That means the bottom left-hand corner of this rectangle we're about to make will start 1/2 inch from the X-axis and a 1/2 inch from the Y-axis. So that's what your anchor point is. That's where the origin, whatever point you select, that's where that point will start. So we have the bottom left-hand corner selected. It's going to start at 1/2 on this XY plane down here. All right, so now we can talk about the size that we want the square to be. So let's just say we're going to make our front and back faces. So we know it's a 12-inch ID box, so we'll go ahead and make the width to be 12 inches and the height to be 10 inches because we have 1 inch foam on top and bottom, so that makes a 10-inch wall height. So there is our front and back side panel sizes. So if I press Create, you see it just pop right down here in the bottom left-hand corner. And that is front and back, so we're going to want 2 of them. So what we can do is we can go to Transform Objects tab and select Mirror. So let's click on Mirror, select the entity that we want to mirror, and let's just mirror it to the right. So you see how it directly mirrored it. The 2 left and right walls of each panel are in contact. That's not necessarily what you want because you do need enough room for your end mill to squeeze by these squares. So I'm just going to slide this guy over about 2 inches. Right there, that should give it enough room for that end mill to pass along the outside of these 2 squares without touching each other. So once that's done, we'll go ahead and close that. So there is our front and back panels. Now we need our left and right panels. So we'll go back to the Create Vectors tab, Draw Rectangles. So this time, I don't want this square to start at 1/2 because if I do, this is what it'll look like. It'll just pop it up right inside of this square we already have. So we don't want that. So we need a new anchor point. We know these bottom 2 squares are both 12 inches long. So we can assume this is 12, that's 12, that's 24 inches. This is roughly 2 inches. We can assume maybe 32 inches in the X direction would be a better place to put that panel. So let's see what that looks like. That looks pretty good. It's a little bit far over. Let's dock it back down to about 28. Create another one. That looks good. Okay, so I just did that just to see where this thing was about to populate. So we can go up to create vectors. I like 28 inches. Maybe we'll make it 26. And it's a 10 by 10. We have 1-inch panels on the front and back, top and bottom. So this leaves a 10-inch by 10-inch square if you're trying to make a 12, 12, 12 box. So 10, 10 is good. We'll create that. And that is a little bit too close. I don't like how close that is. So I'm going to move that entity. And the way we can move it is in the Transform Objects tab. Right here, move selected objects. So I will select, you have to select from left to right, just like SolidWorks. And I'll just slide that over a little bit. So that looks good. Now we want to make 2 of those. So I will mirror it to the left. Go to Transform Objects, mirror selected objects. Sorry, mirror it to the right. Just mirror it, slide it over just a little bit. Looks good. Obviously you don't want to slide too far to the right and get on the other side of this foam panel. This is about as far as I would go. It's maybe an inch or so. So that was good. So now we have front, back, left, right. Now we need to do our top bottom panels. So top bottoms, it's a 12-inch ID box, so 12 by 12 on the top and bottom panels. So we can go up to draw rectangles. So now our X and our Y anchor point are going to change. I'm going to bring my X back to 0.5 and I'm going to change my Y to about 14 inches. And we already said this is going to be a 12 by 12 inch panel size. Click apply and there it is. I want to move that just a little bit. Oh, it took that panel away. Let me go back here. Needed to press apply for the other one. Okay, go ahead and create that. There it is. Let me move this down just a little bit. Go to move selected objects. Move it down just a little bit. Looks good there. Now I need to mirror that to the right because we need top and bottom. So there you go. That's how you can create panels in using V-Carve. And if we wanted to make multiple, say we already knew these sizes were perfect and we're making a job, say we have to make 15 of these boxes. Well, we want to obviously optimize this entire 4x8 sheet. So then you can really start playing with the mirror tool over here and get as many of these panels on this 4x8 sheet as you can to optimize the material. But for the sake of this tutorial, we're just going to stick with these 6 panels. Say we're making a first article prototype. We're not sure if the box is going to fit or not. So this is the case where we would just make one set. So we have the panels drawn. We have them on our board. Our job size is good. It's a 4x8 by 1 inch thick of XPS, just like we want. Now we're ready to make some tool paths. So the difference between cutting foams and cutting plastics is if this was a piece of plastic, we would select all of these, go to the Gadgets tab and select Drag Knife Toolpath. But that's not what you do when you're end milling. When you're end milling, your toolpaths are over here in the top right hand corner. Click Toolpaths. You see all these different toolpath operations. There's a profile toolpath, and what a profile toolpath is, just what it sounds like. You can kind of see in that picture right there. It'll just follow a line and cut it out. So it'll just follow the profile of whatever shapes on the table and cut that out. A pocket toolpath is, for instance, say this is a 1 inch thick piece of XPS. Say we wanted 1/2 inch pockets milled into it for some reason. Say we're going to rivet on a pouch. That's how we could do that. We could draw a little rectangle inside one of these and select that and make it a pocket toolpath. That way it just mills out the pocket, doesn't cut it all the way out. And then we get into some that we don't necessarily use too much. Drilling toolpath. That's pretty self-explanatory there. You can put a drill bit on the end of the CNC and drill actual pilot holes if you're designing a mold or needing places for rivets to go in. We don't use that one too much. And the rest of these we never use. These are for etching and doing engraving on different stuff. This is like fine tuning. We don't ever use any of these. So these are the 3 ones that we mainly use: profiles, pockets, and drills. So let's get started on making these tool paths. We know for all 6 of these panels, it's just going to be a standard profile cut. So what we can do is select them all. We'll hit J on our keyboard to make sure all of the vectors are joined. Looks like they are. All 6 of them are closed. That's good. So we'll close that. And then we'll go back over here on the top right to toolpaths. We'll select profile toolpath, and that brings us to our toolpath options. So there are a lot of things on this, a lot of options with your tools, but we don't necessarily use all of them, so don't freak out. So let's just start at the top. Cutting depths. Our start depth, that is the depth that your end mill is going to start cutting. It's pretty self-explanatory. That is always left at 0. You don't want to put it at 0.5 because that means your end mill is just going to plunge through a 1-inch thick piece of foam at half an inch. So don't do that. Leave it at 0. 0 will be the top of the material. The cut depth. So I always go a 1/16 extra, whatever you think the thickness that you're working with is. So we have a 1-inch board here, so I'm going to make the cut depth 1.06 inches, 1 1/16. And I do that because sometimes that CNC bed is not perfectly level, so it might cut out panels on a certain section and then leave some panels partially cut. And that's really annoying to have to deal with, so I just go ahead and go a little bit deeper than what it says and give it a 1/16 more. So that is the cutting depths. Start depth's always 0. Second depth is always thickness of whatever you're working on plus a 1/16 of an inch. Now let's go to talk about end mills. This is where, say you're doing fine tuning, you're making like a bunch of really small panels on a bed. You could select a smaller end mill. We generally use 3/8 end mill. That's what 0.375 inches is. That's the end mill diameter that we typically use to cut foams. We do have 3/16, we have 1/8 inch, we have half inch. So we have some different sizes, but in general, let's just go ahead and stick with 3/8 of an inch. And if we need to use a different size, we'll talk about that before we start the job. So 0.375 is good. We'll talk about all of these tool information over here. The diameter, obviously 0.375 is what you want because that's what you have selected. So what we are kind of concerned with here is the feeds and speeds. So the spindle speed, whenever you're cutting foams, generally it'll be at 18,000 RPMs, and that's perfect for XPS. What speed rate or what spindle speed dictates is the finish that of whatever material you're cutting. It can make it very, very smooth at high RPMs, but if you go too high, cutting foams, you could actually melt it and cause some really jagged, warped edges, which you don't necessarily want. And it seems that 18,000 RPMs is a really good feed rate to go with for cutting these foams. It's a really good spindle speed to go with, 18,000 RPMs for cutting foams. For the feed rate, so the feed rate is how fast the end mill will travel through the material. So what I do is kind of use my finger and just slide it across the desk at whatever is seen there. 1 inch per second. You can kind of visualize that by sliding your finger across the desk. You really don't want the end mill just flying through the foam. You want it to just kind of slowly and steadily, at a nice pace, cut through the foam. And 1 inch a second is probably pretty good for most cases for us. Plunge rate is how fast the head will move into the material. That's not too important. 0.33 inches seems to be standard, so we'll leave it at that. And so that is how you can select your tool and select your end mill and play with the parameters a little bit. So we'll go ahead and press OK. Sometimes this toolpath thing will slide away from me. If it ever does, just click toolpath on the top right and bring that ribbon back out. So the next thing, after you select your tool, we have a 3/8 end mill. Now we need to tell the machine how many passes we want it to take. So a pass is basically the depth. How many times does the tool have to travel around a certain shape for it to be cut out? In general, when we're cutting foams, it's basically 2 passes per inch. So if I have a 1.5 inch thick piece of XPS, I would do 3 passes. If I have a 1 inch thick piece of XPS, 2 passes is perfect. If it's a half inch, you could do 1 pass. So basically it's 1 pass every half inch of foam. So we have 1 inch of foam, 2 passes is good. You can see up here, this yellow stuff here is our material. and the red line is where that first pass is going to take place. That's how deep in the material the first pass is going to go. If I do 4 passes, you can kind of see how it incrementally will cut down. You want to do higher passes when you're dealing with thicker material. You're cutting metals and woods and stuff like that. You really want to bump your number of passes up so that you can cleanly cut through those materials and not just tear it off the table. But foams, low density foams, it's just fine just to do 2 passes and get it done and get out of there. So that's good. We'll go ahead and press OK for that. And now we will the machine vectors. So this is actually pretty important. So this dictates how the orientation of the end mill as it's doing profile cuts. So you can see this rectangle here, and this little red line, these yellow balls indicate the tool. So what this is saying, an outside right cut, what that says is that the tool will follow on the outside of the vectors and travel in a clockwise direction. So if I click inside left, you'll see that tool change. So now the tool is on the inside of the vectors, traveling in a clockwise direction. The way that we design these panels is we have the OD being what we want, 12 by 12 here, 10 by 10 here, and 12 by 10. So we want that tool to cut on the outside of those lines, not on the inside and not on the line, on the outside of the line. So that's a really important parameter to make sure that is correct, or else your panel is going to come out 3/8 smaller than what you planned for. So we'll go ahead and go down to the next one. Pretty much all of these next parameters you don't ever have to touch. These top 3 are the most important: cutting depths, your tools and passes, and then your machine vectors. Those 3 things are the most important, and they're the only things of any importance on this. We don't have to mess with any of these. So once those 3 have been addressed, we can go ahead and press calculate, and you see this little window pop up. It says you're cutting at a deeper depth than what your material thickness is. We know that. I explained why we're doing that, so we'll go ahead and just press OK. We know that we have a bleeder board out there and everything's safe. We know that we wanted to go a 1/16 deeper than the material thickness, so just press OK. And you see yourself go into this kind of a 3D zone here. With a left click on the mouse, you can control this board, and if you ever want to go back, to go ahead in this top right corner, you can zero it to whatever axis you want. Z-axis is what's perpendicular to us, so if you ever move it around, you can just click the Z-axis right here and just bring it right back. So this is a 3D space is what this is. And if you want to go back to the 2D space that you didn't mean to press calculate, up here in the top left, you go back to the 2D view. 3D view, 2D view. So we'll click on the 3D view and kind of show you what this does. So after you press calculate, it brings up this preview pane, and you can actually watch the job that you just set into motion. And so some jobs can take a long time, and the speed's pretty crazy on this software. So our jobs are usually pretty quick. So just drop the speed all the way down, or else you won't even be able to watch it. It'll just be over in a millisecond. So if I press play, preview all toolpaths, you'll start to see all of them being cut. There's 2 passes on each one. You saw how fast that was in itself. So, I mean, if you turn the speed up and you're trying to watch this, it's just instantly over. So just turn the speed all the way down if you're watching previews. This can be important. It can tell you if you actually do have enough room between these panels. Like right now, I probably wouldn't cut these because these are just too close together. You don't want to leave, no room for error. And these panels, if it's too thin in between them, the end mill can actually start to slide the panel out of the way and mess the dimensions up. The vacuum, it can't hold vacuum that well if you're cutting them this close together. These top panels here, that's a good amount of material that you want between them. All of these down here, I would say, are too close. Really want to give them a solid an inch between each other, just so there's enough material to keep them held down. So that is the preview pane. Preview all toolpaths. Just kind of watch what you did, make sure it makes sense. You can reset the preview and just watch it again if you want to. So that's what that is. It's a cool little feature. And once we're happy with it, we can just press close and just get out of this. And now it's the same as saving those drag knife tool paths. We have our tool path right here that we just made. It's a 3/8 in mil, 16th inch cut, and what we can do is just in the bottom right hand corner is save the tool path. And save toolpath again, and we can just go on the desktop or flash drive, wherever you're saving it, and save it. So say we'll just make a V-Carve tutorial folder. And so naming convention whenever you're saving in mill CNC cut jobs is we'll just call it what it is. So we'll say this is an R12 foam panel set, and then you have to tell the user, what end mill should they use. So we'll say 0.375 end mill, and that is good for the naming convention. So tell it what it is, and then say what end mill you're using. That way, if another tech or somebody else needs to use this G code, they don't have to wonder, was it a 1/2 inch end mill, was it a 3/16? You're telling them right here, this is a 3/8 end mill, and this is what you're cutting, R12 foam panel set. And it is a .tap file, so we want to G code, and we'll press save. And also, same thing as with the plastics, and we go back to 2D view here, you need to save this V-Carve file. So just because you save the G code into your flash drive or wherever doesn't mean that this V-Carve file is saved. So on the other side, just save as the V-Carve, you see .crv. That way, if you need to make any changes, say these panels were too close together, they moved, you had to come back in here and make some adjustments, you don't have to start completely over. You can just use this same V-Carve file. So make sure you do save those. We'll go ahead and press save. And that's it, guys. That's how you can use V-Carve to cut out foam panels. Thanks for listening to this tutorial, and we'll see you next time.